right there, a lot of the background galaxies and so on. But that just shows you that at least what they're seeing in these other areas of light are kind of consistent with what's going on. Another one that I came up with that kind of caught my eye was the some recent studies with the Crab Pulsar and the fact that it is putting out gamma rays. The Crab Nebula and the Crab Pulsar was a supernova explosion in 1054 AD, recorded in the Orient. Apparently it was cloudy for a whole year in Europe, where people didn't want to get burned at the stake, one or the other. Didn't want to say anything changed in the sky, but had this star bright enough to see during the daytime, appears differently. And well, when the star explodes, supernova explodes, and the center collapses into a very small object, and it's about maybe the size of the city of Binghamton, like a big atomic nucleus, a neutron star, and coming out its north and south magnetic pole are beams of radio and X-rays, and that stuff is coming around. You can even, this one you can even see in regular light. Coming around, it just so happens that beam comes right past us, and if you had a radio telescope right now, it would have like a clicking sound. But nobody really thought that it was so powerful as putting out gamma rays. Well, recent discovery, yes it is. So that means back to the drawing board on exactly what's going on with this supernova. Now, what we have here is a Hubble Space Telescope image and a artist's conception of what these beams are looking like, and they're coming around as such. A gamma ray photon is probably about 1 million times more powerful than the X-ray photon. If you had a dental X-ray recently, what you're getting there. So, very interesting stuff. Again, astronomy, a lot of times science moves together forward incremental. Small little observations add support or provide information. We don't have big jumps like the possible recording of the Higgs boson in physics. But this year we had a lot of little incremental things that move forward, and this is just one additional observation that will force us to rethink some of the theory. That's the picture of the same object taken with the our 20-inch telescope out here. Again, with a better camera and a longer exposure, I'm sure we can do better than this, but gives you some idea what we've been doing here in probably a couple of years. This one, closest Type 1A supernova index. These guys, back in August 24th, 2011, discovered this supernova, and the interesting thing about it is a Type 1A supernova. They're all the same brightness. They're closely related to how we measure distance to galaxies and galaxy rate expansion. And a number of KS members were at Cherry Springs Star Party the day that they discovered this, and were able to see it visually in a telescope. So here's what it looks like. It's always easy to find supernovas because they have these big arrows pointed at them. But you look real, this is like a H star forming region in this galaxy. The rest of these stars are maybe at the most 1,000 light years away. And this star is 21 million light years away, and it's brighter than these guys. So that tells you it's a really bright explosion. 21 million times, roughly, 21 million times brighter. And it could be even brighter. And just, again, notice this. And this line of stars here. Here's the image we took with our 20-inch. There's the line of stars, nothing. So obviously we missed that supernova. We've gotten a lot of them. We've been taking about 300 supernovas here over the years, but there's just one of them in another galaxy. And I am getting the cutthroat here lead, so I'll just kind of run through that. There's M13 through our telescope up there. So I'm glad everybody came here. I hope you enjoy Astrofest 2012, and I will turn it over to the next speaker.